Hello everybody, it's Mr. Ray here. Welcome to the first lesson of the grade 12 data management course. We're going to be starting with the first of 5 units in the course. The first unit is called permutations and combinations, and I know that's a mouthful. These are 2 terms that we're going to get to know in the next few lessons, but a more general way of describing what this unit is how can we count things? And I know that sounds very simplistic. Everybody learned how to count when they're 5 and 6, but this is for counting more complex situations. And once we start some examples, you'll see where that's coming from. Okay. So just so you know, combinatorics is the branch of math that we're talking about here. It has to do with the methods of counting in complex situations. So permutations and combinations fits under this branch of math. Okay, there's going to be 2 main principles we're going to be using in this lesson. One is called the multiplicative counting principle. Okay, and the other one is the additive. So you'll choose one or the other, and I guess there's some situations where you might use both, but generally it's one or the other. You have to look at the situation that you're dealing with, and through the examples you'll get a better feeling for how this works. But by the definition, if what you're looking at is made up of stages with separate choices for each stage, then the total number of choices for the entire task or process is the number of choices for each stage multiplied by each other. So for example, in this definition here, if the first stage had m choices, second choice had n choices, third choice had p choices, etc. If you want to know the total number of choices for the entire process of using all these stages, you just multiply the number of choices of each stage. Okay. And this will be the more common thing we do in this lesson. There's also something called the additive counting principle, and this is where you have mutually exclusive actions. Okay, so and we'll do a couple of examples of this as well. So when you have m ways of doing one action, n ways of doing a second action, p ways of doing a third, but you're not going to be actually using all 3. You'll just use one of those 3 choices. Then what we do is we just add these number of choices up. So unlike the first multiplicative counting principle where we multiply all the number of choices, this time we add them. Okay. Now a very important key for knowing when you should use one or the other is by the 2 words and the word or. So if you look at a question and it's giving you, for example, how many ways can you choose an appetizer and a main course, the word and between says, well, I'm going to find out how many choices there are for the appetizer and how many choices are for the main choice, and multiply those 2 numbers together. That will give me the total number of choices. The additive counting principle uses the word or. For example, how many ways can we roll a 6 on a die or draw a jack in a deck of cards? So in that case, we're not multiplying the distinct choices of rolling the number and picking a card. We're adding them together. Okay, so so the word and means you multiply the choices, and the word or means we add the choices. Okay, now one of the ways, and this applies to the multiplicative counting principle. A tree diagram is a very useful method, at least to get started. After a while you'll go, okay, I get the idea. I don't really want to draw a tree diagram, but you still have to show that you know how. For example, this this tree diagram, you can see, well, in a way, it sort of looks like a tree. I guess if you turn it on its side, you're starting down here with, your three main branches of the tree, and as you go up, it branches off into more and more branches. Okay, and we could draw the tree, going up or coming down, but generally we'll draw it going left to right. So in this example here, this could be your choices for your lunch. So for your main part of your meal, you have a choice between a hot dog, a burger, or a pizza. Okay, so I've got three choices for my entree, if you want to call it that. For a drink, I've got three choices as well. I can choose milk, water, or soda, or as we say in Canada, pop or soft drink. So you can see I got the same three choices for hot dog, burger, and pizza. So I've drawn branch off the hot dog with my three drink choices, a branch off burger with the same choices, and a branch off pizza. So you can see how this is growing into a tree sideways. Okay, and then for my dessert, I have a choice between ice cream and cake, and that applies to every choice I've made so far. So each of the branches that I'm left with here, I also have a choice of ice cream or cake, so I draw off each of these a second branch for ice cream and cake for each of these. So by the time I get to the end, I can see how many total choices I have. I can add all these end branches up. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 different lunch combinations that I could choose from. Okay, so that's the way a tree diagram shows you how to organize your counting. You can see if I added a fourth and a fifth choice, it can get pretty daunting with how many branches we have off here, and that's the main drawback to the tree diagram, is it gets a little out of hand. So when you're actually doing a tree diagram, make sure you leave yourself enough room. You can see how much room we left for it between these choices, and even with that much room, it was pretty squeezed in at the end. So that's one of the recommendations for a tree diagram. Give yourself lots of room, and hopefully you end up with something that's readable at the end. So again, we just count up how many of the tips of the branches at the end do we have, and that's the total number of choices for this situation, our lunch choices. Okay. These two items in the key concepts, just repeating the multiplicative counting principle, where we multiply the number of choices. And if I went back to this situation here, this is a multiplicative because I'm choosing. If I looked at this, I'm choosing a main course and a drink and a dessert. So the fact that these three things, the main course, the drink, and the dessert, those are different choices to be made. So when I could actually put the word "and" between them, main course and a drink and a dessert. So I could actually use this multiplicative principle, and the way that works for this choice, I actually have three choices for my main course, my entree. I've got three choices for my drink, and I have two choices for the dessert. So since these are ands, these are multiplicative counting principles, I can just multiply the three numbers, and from that I'll get 9 times 2 is 18, which is the same number that we had by the tree diagram. Okay, so obviously this is a lot quicker, but this is a good visual way of representing the number of choices you have. So you do have to be able to show me that you understand how to do a tree diagram and how you use a tree diagram to come up with the number of options or choices. Okay, but after a while, you'll, like I said, if we had two other choices of, like type of plate, or maybe a vegetable choice, something like that, you'll see that this tree diagram gets a little out of hand very quickly. But if you're doing just the math part with the multiplication, if I had 2 choices for the type of plate and 4 choices for the type of vegetable, I just add a ×2 and a ×4. A lot quicker than doing the tree diagram, but like I said, you still have to be able to show how to do a tree diagram and how you can use the tree diagram. Okay, one last thing here is, and this is a very important thing for the rest of the course, not just this lesson or this unit. We'll be using this a lot. So the indirect method is a way of counting, and we do an example of this in a few minutes, but sometimes it's easier to count the ways of not doing something instead of counting the ways of doing something. If you count the ways of not doing something and subtract that from the total number of ways, you can do your subtraction. Subtract the number of ways of not doing it from the total ways, and you'll get the ways, the difference will be the number of ways of doing that thing. Okay, so sometimes it's much easier to do it this way, so keep that in your back of your mind. Okay, and yeah, once we get into the other units, you'll see indirect method is a very, very good tool to use in terms of helping speed up getting your answer. Okay, so we're going to do some examples here. Now these are from the textbook, so feel free to use those examples if you care to. So here's example 1. Martin lives in Kingston, is planning a trip to Vienna, Austria. He checks a website offering inexpensive airfares and finds if he travels through London, England, the fare is much lower. Okay, so to get to London from Toronto, there are 3 flights from Toronto to London and 2 flights from London to Vienna. Okay, if Martin can take a bus, plane, or train from Kingston to Toronto, so it's getting a little complicated here. Lots of places. So let's start off with just a kind of a little diagram, arrow diagram. He's starting off in Kingston. From Kingston, he's going to go to Toronto, and then from Toronto, he's going to fly to London, and then from London, he's going to get to Vienna. Okay, and you notice I was using the word "and" a lot. He wants to go from Kingston to Toronto, and from Toronto to London, and from London to Vienna. So I'll start this off with a tree diagram, and then do basically the direct method of the multiplicative property. So just so we get a little experience here. So to go from Kingston to Toronto, if we go back here, Martin can take a bus, plane, or train from Kingston to Toronto. So we're going to start off with this branch of the travel. So Kingston to Toronto, he can do a bus, a plane, or a train. Train. Okay, and then so if I was to start off with where he is now, so that's Kingston, right? So Kingston is here, and then Toronto, he gets there with the 3 choices. Now, once he's in Toronto and he wants to go to London, there are 3 different flights. So that means from each of these, I'm going to have 3 branches. So I'll just put flight F1, F2, F3 for the different flights. And I have to repeat that again for each of the methods that he got to Toronto. F2, F3, F1, F2, F3. Okay, so that takes him to London. Okay, you can see this gets a little messy. So basically he started in Kingston, he took one of these 3 methods to get to Toronto, and then Toronto, he had 3 choices to get to London for flights. So now he's in London, he wants to get to Vienna. Now, London to Vienna, there are 2 flights. So then from each of these branches, you're going to have 2 branches off those. And you're seeing now the disadvantage of doing, so I'll call these, again, F1, F2. These are different F1, F2s, of course. It's getting very squeezed. So it's, yeah, definitely good planning is a good thing for this, drawing your tree diagrams. Okay, so at this point, this is getting squeezed here as well. This takes them to Vienna. Okay, so if I looked at each one of these end branches here, that represents one way of getting from Kingston to Vienna. So for example, if I chose that branch there and work my way back, okay, so if I follow my path here, that path says that Martin took a plane to Toronto, then he took the third flight option from Toronto to London, and he took the second flight option from London to Vienna. That's one of the many choices. So again, if you count up, how many do we have? These end branches. Probably going to forget one here. So I got one. Count up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I forgot one here. 1, 2, 3, 4, 5, 6, 7. I'll just count it 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. I'm double counting. Hold on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. So we have 18 ways to travel from Kingston to Vienna. Okay, so that's using the tree diagram. Now, if I was to use the more direct math of multiplicative counting principle, I could say, well, I've got 3 choices. I got 3 choices to get from Kingston to Toronto. I've got 3 choices, and I have 3 choices to get from Toronto to London, and I have 2 choices to get from London to Vienna. That works out to 18 ways as well. So same number, different way of doing it. Okay, so hopefully that helps. Excuse me. The next question, we're going to skip the tree diagram and go direct with the multiplicative principle. So Javon is looking at stereos in an electronics store. The store has 5 types of receivers, 4 types of CD players. You can tell this question is a little dated. And 5 types of speakers. How many different choices of stereo systems does the store offer? Okay, so number of stereo systems, so a stereo is all 3 of those things, is equal to, okay, so the first thing, I've got 5 types of receivers, I've got 4 types of CD players, and 5 types of speakers. So I'm choosing a receiver and a CD player and speakers. So I just look at the number of options for each and multiply them together. So I've got 5 choices for the receivers. I've got 4 choices of CD players and 5 types of speakers. So multiply those together. I've got 100 different stereo systems that could purchase. Okay. That's a lot nicer than doing a tree chart. You must agree with me there. Okay. Let's look at a couple more examples. A school band often performs the benefits and other functions outside the school, so its members are looking into buying band uniforms. The band committee is considering 4 different white shirts, dress pants in gray, navy, or black, and black or gray vests with the school crest. Okay. how many different designs for the band uniform is the committee considering? So again, this is, if you look at if we just summarize what we've got here, we're buying white shirts, and we have 3 choices for that. Dress pants, we have gray, navy, or black, so that's 3 choices. And the vests with the school crest, we have black or gray. That's 2. Okay, so if I want to know the total number of uniform designs that are being considered, okay, now we're choosing white pants and dress pants, white shirts and dress pants and vests. So that means we're using multiplicative of multiplying all the choices of each. So that's 3 times 3 times 2, which is equal to 12 times 2 is 24 different uniform designs. Okay. So this question was a little different than the last. The last question gave you the numbers in the question. So it's just pulling the numbers out, whereas this question, it listed the choices. So it was kind of good to summarize the number of choices of each uniform part. So I can go directly from here to the equation to calculate the number of uniform designs. Okay. Now, you can tell by the title here of example 4, this is where we're going to use the indirect method, and hopefully it makes sense. Okay, Leora, a triathlete, has 4 pairs of running shoes loose in her gym bag. So a total of 8 shoes. You've got a left and a right for each pair of shoes. How many ways can she pull out 2 unmatched shoes, one after the other? So this is basically, she's got her gym bag. It's filled with 8 shoes. How many different ways, the question's asking, how many different ways can she pull out 2 unmatched shoes? So this is quite a bit trickier than the previous questions. Okay, so if you start thinking about using the direct method, which is the way we did before, you have to look at all the different cases, because there's a left and a right shoe. There's only certain shoes that will match. It is doable, but I'll show you the indirect method here. So the indirect method is you always start off with the number of ways, the number of total ways of doing this process. So this is the number of ways to choose 2 shoes. Okay, so and this is something we'll be doing a lot of later on in this unit. So if you've got 8 shoes in a bag and you pull one out, how many different shoes could you pull out? How many different shoes? Well, it'd be 8, right? So you've taken out 1 shoe, you've kind of set it aside, it's out of the bag now. You've got 7 shoes left in the bag, so you choose 1 more shoe. How many different ways are there to choose that 1 shoe? Well, there's 7 shoes, so you have 7 choices for that second shoe. So I've got 8 choices for the first shoe, 7 choices for the second shoe. So I've got a total of 56 ways of choosing 2 shoes. Okay, so we're going to use this to actually calculate what we're looking for. Now for the indirect method, we're being asked how many ways can she pull out unmatched shoes. So the indirect method would be how many ways are there to pull out 2 matched shoes. Okay, so number of ways to choose 2 matched shoes. Okay. Now, it can get a little confusing, and there's different ways of doing this. I think the easiest way to think about this is, okay, if I'm going to choose 2 matched shoes, well, I've still got the 8 shoes in the bag. I'm going to pull out one shoe. Okay, so again, I've got 8 choices to pull out that first shoe. Okay, now, in order for the second shoe to be matched, right, it's no longer 7 because there's not 7 shoes that match the one we just took out. There's only one shoe that matches. For example, if I pulled out the left blue shoe, okay, out of the 8 shoes, well, there's only one match, and that's the right blue shoe out of those 7 shoes. So the second shoe, there's only one way to match up the shoes, so that would be 8 ways of choosing matched shoes. And you might think, well, why is it 8? Because there's only 4 pairs of shoes. Well, I might have picked the left blue shoe as my first choice. Okay, so there's only one match for that. If I pulled out the right blue shoe first, there's another way of choosing 2 matched shoes. I could pick either the left or the right for each type of shoe, and then pull out its matching shoe, and then there'd be 4 different types of shoes. So you could look at this as maybe 4 times 1 times 2, thinking about left and right, but I think this is a little easier. You just think I'm pulling out any of the 8 shoes, and how many shoes will match that shoe? Well, there's only one. So there's 8 ways of choosing 2 matched shoes. So this is where we do the indirect method. So the number of ways to choose 2 unmatched shoes. Okay, now I'll do this the long way. That's equal to the number of ways to choose. This is a lot of writing here. To choose any 2 shoes. The total number of ways to choose 2 shoes minus the number of ways to choose 2 matched shoes. Okay, and we just did those calculations. Number of ways to choose any 2 shoes is 56. And we subtract the number of ways to choose matched shoes. That's 8, so we have 48 ways. Okay, so that's what we call indirect method. In order to find something you're looking for, maybe it's easier to find the cases or the situations that you actually don't want, because that might be easier to calculate. And in this case, it was. So that's what we refer to as the indirect method. Okay, and we're going to be using that a lot in this course, so please make sure you understand the idea of indirect method. Okay, one last example here. So signal flags, these are sailing ships used to send messages with signal flags flown from their masts so that boats from far away could see them. How many different signals are possible with a set of 4 distinct flags if a minimum of 2 flags is used for each signal? Okay, now this is a lot more complicated than it first looks like, because you know there's 4 distinct flags that you could choose from, but you don't always display the 4 flags. You could display just 2 or 3 or 4. So this is a situation, you just heard me use the word or, okay, 2 flags or 3 flags or 4 flags. So we're looking at different cases or different parts to this solution. So I'm going to break it down into the 3 cases. There's a case where we have 2 flags. There's a case where we have 3 flags. And the case where we use all 4. Okay, now what it doesn't say here is the order is important too, right? You might have a yellow and a red flag that you're using. Well, yellow-red is different than red-yellow. That's a different signal. So we have to consider the order as well. So if I'm looking at the 2 flags, well, you know, how many ways can I choose that first flag? Well, there's 4 different ones I can choose from. So I got 4 choices for the first flag. I'm using that. So for my second flag, I only have 3 because I've already picked my first flag. So I have a total of 12 different signals. Okay, if I use 2 flags. Okay, so it continues on. If I use 3, very similar looking. I've still got 4 choices for the first flag. I still have 3 choices for the second flag, but now I'm using a third flag. Well, I've already used 2 flags out of the 4, so I have a choice of 2 others for the third flag. So now this is basically doubled for the number of choices from the 2 flags to the 3 flags. And then for 4 flags, same idea, 4 times 3 times 2. But by the time we get to the 4th flag, we really don't have a choice because there's only 1 flag left to choose. But we'll still write it here anyways to show that first flag, second flag, third, and 4th. So it doesn't look the same as the 3 flags, but the actual number of signals between 3 flags and 4 flags is different. Sorry, is the same, but the actual signals are different because obviously this one has, these 24 have 4 flags, these 24 have 3 flags. Now, I mentioned earlier about using the word or, so it's 2 flags or 3 flags or 4 flags. So what that means is that we actually add these up. So this is additive property. So it's 12 plus 24 plus 24. That's going to be 60 different messages. So maybe you recall at the beginning when I was describing the multiplicative versus the additive principles. Well, this question actually used both, because in order to find out how many combinations for signals using 2 flags or 3 flags, each of these calculations was using multiplicative principle, but when I combined all 3 together, I used the additive. Okay, now the reason why I'm not multiplying 12 times 24 times 24, if you think about it, if I replace the words or here with and, 2 and 3 flags, sorry, 2 flags and 3 flags and 4 flags, well that doesn't make sense because I can't have a signal that has 2 flags and 3 flags and 4 flags. It's one or the other. So this is where the additive principle comes in. You have your 3 different cases that you've used the multiplicative principle for, and then you choose one of these 3 things. So that means you're adding up the combinations for each. So you have 60 different messages. Okay, so hopefully that gives you a good idea of, well, we looked at tree diagrams, we looked at, looking at the multiplicative principle. We did a few examples of that. We also looked at the indirect method of counting when we used the unmatched shoes. And also we looked at the additive principle when you're looking at 3 different options. You pick one of those 3, not all of them. Okay, so homework questions, as always, will be at the bottom of the lesson note. So you can do those, and I'll be posting the solutions for those a little later. But since these are in the textbook, you can check your final answer to see if you got it right. If you're having problems with the actual method or steps to get the right answer, that will be part of the solutions that I post. Okay, so that's it for today. We'll see you on the next lesson. Have a good day.